I was learning multiple recursion calls, like the basics of multiple recursion calls. So let's have an overview on the topic. To learn multiple recursion calls, dealing with Fibonacci number is a great way. So what is a Fibonacci number? A Fibonacci number is a number in the Fibonacci sequence where each number is the sum of the two preceding ones, starting from 0 and 1. So in the Fibonacci sequence, the starting number will be 0 and 1, and the next number will be the sum of these first two numbers. Like if I need the third number, it will be the second one plus the first one. The third number will be 1 plus 0, 1. The next one will be 1 plus 1, 2. And the next one will be 2 plus 1, 3, and so on. So we have to write a function where we will give the nth position. We'll give the position of the Fibonacci sequence, like the position will be 10 or the position will be 5. So like if we say the nth position is 10, so it will return us 55. So we have to do this through multiple recursion calls, okay? So first, say one thing. If this is like nth position, okay? If this is nth position, how can we get this one? Can we say this is nothing but this one plus this one? So what is this? Isn't this n minus 1, nth position minus 1? And isn't this nth position minus 2? So what can we do to get this one? We can easily say we have to sum this one, n minus 1, and sum this one, n minus 2, to get the nth position. So we will do it right now. So let's move to the code. Here I will declare a function. And let's say I will name the function f. And through the parameters, wait a second. And through the parameters, I will take the position, nth position, okay? So inside this function, we will declare two variables, okay? So we will declare the first one, let last number equal to function of n minus 1, okay? And the second last number equal to f of n minus 2, right? And then in return, we will just multiply, we will just sum these two numbers, second last number, okay? And then we will print, we will print the function of, let's say we need the Fibonacci number of fourth position, okay? Fourth position. So what will happen now if I run this code? This will run into a loop because we haven't declared the base case here. In the recursion function, we haven't declared a base case. So first it will run into a loop, and then eventually it will overflow the stack. So it will give us the error, stack overflow. So we have to declare the base case here. And what will be our base case? Our base case will be if n is less than or equal to 1, just return us the n, okay? So why we are doing this? We are doing this because this function will run again and again, and eventually they will come here to 1 or to 0. If they come here, we need to just return the function, the value of the n. So that's why we're writing it here. Okay. So if we now run the code, it will give us the fourth Fibonacci number. Which one? This one. Okay. 1, 2, 3, 4. Okay. Let's see. It's giving us 3. Okay. So this was the code. Now let's see an overview here. What's happening inside the function. Okay. Let me just select it. Okay. This here. So what's happening here? When we are coming to this line, this is summing function, the recursion function here, this one, nothing else. So if we if we just sum this one and this one in the return statement, it will again call this function and this function, which is basically this. So when we are coming to this line, like here, it means here, right? So I will just indicate this one, okay? Not here. It will be really hard to draw here, okay? So when it's coming on this line, it's recalling itself, okay? Recalling itself here. It's recalling itself and passing here. We are passing the number 4, right? Okay. Let me just remove this line from here. Okay. Okay. So we are passing 4, the position and position 4 from the parameters here. We are receiving from the parameters here the 4, and where we are coming this line, basically this line, but for the purpose of drawing, to make it easy, I'm just referring it here, okay, so that I can refer from here to here and here from here, okay. So when it's coming here, it's again calling itself, and through the parameters, it's giving n minus 1. What was our n? It was 4. What will be it? N minus 1, 4 minus 1, 3. So we are here receiving nothing but 3. Okay. Let me just write it in a better way. Can I write it with mouse? Yeah. 3. We're receiving here 3. Okay. So when it's coming here, this isn't executing yet. Okay. Because here we got 4. 4 isn't less than or equal to 1. So it's not executing. It's not returning anything. It's just going to the next line. Okay. Same here. It's not executing. It's going next line. Again, it's coming here, or you can say here, okay, for better understanding. You can say here, but actually it's happening here, okay. So when it's coming here, it's again calling itself, okay, like this, like this. Here we're getting the n as 3. So here we'll get n minus 1 equal to 2. Here we'll get 2. And remember, these functions, this function isn't executing yet. Why? Because our this function or this function or this function this function or this function it's still averaging in the stack. So the next one isn't executing. This function is paused here, or you can say here. It's paused here until we finish these calculations. When will these functions will return a value to this, then this will execute. When this will return us something, then this one will execute. These are not less than or equal to 1. So this will not execute. Again, this will call itself, okay? Again, this one will call itself like this. And here we're getting 2 minus 1 equal to, let's say 1, okay? Now, our n is less than or equal to 1. So what will it return? It will return n. What is n? 1. So this will now return n here. 1 here, okay? 1. Now, this line will execute, or this one will execute, okay? So now this function will call itself again here, okay? So here we have n, which is 2. So this one will be n minus 2, means 2 minus 2, which is 0, okay? Let me draw. This will go here, 0. And 0 is less than or equal to 1, okay? It's not equal to 1, but it's less than 1. So it will return 0. It will return n. And what is n? It's 0. So this will return 0, okay? So now in this function, we have the value of last Fibonacci number and the second last Fibonacci number. This one is 1 and this one is 0. So this function will return 1. 1 to this. This will be 1, right? And now this line has been executed, or this has been executed, okay? So now this one refers to this one. This one will call itself again here, okay? And here we have the n as 3. So 3 minus 2 equal to 1. Here the n will be 1. N is equal to 1. It will return the n. What is n? N is 1. So this will return 1 here, okay? So we have got 1 here and 1 here. So it will be 2, okay? So this function will return 2, right? And here we have n as 4, okay? N as 4. So this line has been executed. Now this one will execute now. This one again will call itself. Yeah, right? So we have 4 as n. So this one will be 4 minus 2, which is 2. We'll get 2 here, okay? So is 2, is n or 2 less than or equal to 1? No, this will not be executed. Okay. Now this one will come here, okay? Here, or it refers to here, okay? So this one will again call itself, okay? Like this. And here, the number, the n will be n minus 1, which is 2 minus 1. This will be 1. This will be 1, okay? So n is equal to 1. Means 1 is what equal to 1. It will return n. What is n? N is 1. So it will return 1. Now this have 1. Okay. This have 1. Okay. So this line has executed. Now this one will execute. Okay. Like here. This one will execute. We have n 2. So this one will be 2 minus 2, which is gonna be 0. N is less than 1. Like 0 is n less than 1. This will execute it. It will return n. What is n? N is 0. So this will return 0. Now we have this one as 1 and this one as 0. So sum of these two is 0, is 1. So this function will return 1 here. Okay. And we have the values of last Fibonacci and the second last Fibonacci. Here we have 2 as last Fibonacci and the second last Fibonacci as 1. So sum of these two numbers will be 3. So answer will be 3. Here we have answer 3. Okay. So now let's have an overview, have a look on the recursion tree. On the recursion tree, where is that? Yeah, here. Let's have an overview on the recursion tree. This is the main function, right? This function calling two function f of 3, f of 2. We know this is calling n minus 1. N minus 1 is 4 minus 1, 3. And n minus 2 is 4 minus 2, f of 2. This is calling two functions, okay? So which one will execute? This one will execute, and this one will wait until this executes fully, okay? And now this one will execute two functions, this one and this one. Which one will execute? This one. And this function will call two functions, this one and this one. Which one will execute? This one. And we have got here n as 1, okay? We have got here n as 1. 1 is equal to 1. So this one will return 1, right? Return 1. So this has been executed. Now this one will execute. This one will return as 0. Return as 0. So 1 plus 0, 1. This one will return 1. Okay. This one will return 1. Now this one will be executed because we have done this. This one will execute and return 1 because 1 is equal to 1. This one will return the n 1. Here we will got 1. So 1 plus 1, 2. This will return 2 to the main function. This will return 2 to the main function. Now this one has been executed. So now this one will execute. It was waiting until this executes. So this one will call true function. This one and this one. This one will return 1 because we have written the condition. If n is less than or equal to 1, return n. This will return n, which is 1. This will return n, 1. Now this one has been executed. Now this one will execute. This one will go, and as the condition, it will return n, which is 0. This will return 0. So sum of these two, 1 plus 0, will be 1. So this function will return a 1. And now the main function will sum these two numbers, 2 plus 1, which is going to be 3. So our result will be 3. So this was the basics of multiple recursion calls, what I was learning through Fibonacci number. So that was it for today. Thanks for watching.